Okay, let's just do 2 questions where we are going to simplify 2 expressions. So let's get a different color here. All right, now remember when you're simplifying expressions, what you're trying to do is you're trying to get these fractions to be one fraction. That's the goal. All right, so you look at the denominators on both of them. They're not the same. Now, this one has a 3x, this one has a 3x, and an x plus 1. So what do we need on both denominators from to match? We need 3x and x plus 1. Now, if I have an x plus 1 over here, does this fraction need anything else to match this one? Actually, it won't, right? So what we're going to do, remember when we're simplifying rationals, is we have to multiply top and the bottom by whatever it is that you need on the bottom to make the denominators match. All right, so we're not going to touch the fraction on the right because it doesn't need any adjustments actually at all. Okay, so on the right, we won't touch it, but on the left, we're going to have 5.
Mr. John, can you please come to the front office, please?
And x plus 1. And then on the bottom, we have 3x and x plus 1. All right, then on the right fraction, nothing's going to change, so I'm just going to transfer all that over. Okay, so we don't want to cancel anything over here because that would just take us right back to the original problem and that wouldn't get us anywhere. But what we do want to do is distribute what we have on the numerator here. So that would be 5x plus 5, and that is still over 3x and x plus 1. And then let's bring this other fraction down again. Remember, we aren't touching it because now we have denominators matching. So when the denominators do match, what's your step to do after that? All you need to do is combine the numerators. Now, since this is addition, we can strictly just look at these two numerators and combine them, just adding like terms. So 5x plus 5 and 3 is going to be 8. And then on the bottom, we will still have 3x and x plus 1. And there's no way to reduce anything. This x cannot reduce with that because that 5x is part of that expression, 5x plus 8. So it can't touch that. But that's all we can do on that one. All right, let's try another one. All right, so again, we're trying to get these two fractions together. And there's no way by multiplication to get x minus 3 to look like x minus 4 or vice versa. So this is that worst case scenario where I have to multiply each fraction by the opposite denominator. So this is what we're going to do. And I've been trying to get y'all to section off your work when you do a problem like this because it really does help. It lets you see, what it is that you've got to work on. All right, so on the left fraction, we've got 4, and we need to multiply it by x minus 4. One thing that I've noticed is if y'all don't write this step, you're not distributing completely. So let's just write it out. It's x minus 4, x minus 3. On the bottom, I'm not going to multiply those out because it's not really necessary. All right, and then on the top of the right fraction, we need 3x. We need to multiply it by the entire expression of x minus 3. All right, so what we want to do now is start cleaning this up. We do want to distribute on each of these fractions to see what we have. So on the top left, we're going to have 4x minus 16. All that is still over x minus 4 and x minus 3. Okay, and then on the top right fraction, we're going to distribute and do 3x times x. Now that's 3x squared. And then 3x times negative 3 is negative 9 and an x. And still denominator, just bring it on over. Okay, we have the same denominator now. So what we're going to do is write that one time. And then we're going to combine our numerators. Now I would just go ahead and start gathering up like terms from where you are. And this is a plus. If it was a minus, we would have already changed it, but we have no other x squared, so I would write that one first. I see a 4x and a minus 9x, so that would be a negative 5x. And then there's a regular old negative 16 just hanging out there. That's all you can do on that one. We got our fractions together, we got a common denominator, added the numerators, done.